So this review video is going to be on linear magnification of drawings, actual size and magnification. Still all part of 2.1. So this has I guess I should clarify a little bit. This is magnification of a different kind than you saw in your microscopes. This has to do with more drawing size. So what I've done already is drawn a sample, an unlabeled, unidentified bacterial cell. You should already be able to identify some of these structures, like the nucleoid. We've got ribosomes, a plasmid, a cell membrane, a cell wall, pili, flagella. You should be able to identify these things and be able to annotate that as well in the drawing. But the real reason that I drew this here is that this is not actual size of the organism. This is blown up or magnified many, many times so that we can see these things. If you remember correctly, prokaryotic cells are less than 10 micrometers, so very, very small, not on the order of magnitude in which we can see them. So when we draw them much bigger. This target, or this learning assessment or assessment statement, really needs to be more about, you need to have this conceptual idea that it's about how large is the drawing or the image that I'm given. And so really what you have to commit to memory is this formula. Now you can remember it any way you want, but this is the formula that I recommend to you. M equals D over A, where M is magnification, D is drawing size or image size, and A is the actual size of the image. So the drawing size is the blown up size, and actual is what it is in reality. So an important note is that for the D and the A, the drawn size and the actual size, they absolutely must be in the same unit. Otherwise the division doesn't work and the units don't cancel out. So if you were given D in, say, centimeters and actual in micrometers, you're going to have to convert one of those two values to the other unit. And what you're going to need to know and practice your dimensional analysis skills. You might also call that unit conversion, or the fences, if you remember that from chemistry, in order to calculate magnification. Now you can remember any other algebraic version of this formula, but the other one that I had mentioned in class is this one, MAD. That might be an easy way to remember it, but I know that even reviewing some of your quizzes from a couple weeks ago, you got confused about where the equal sign and the multiplication signs go. So maybe M equals D over A is a little easier to remember and keep straight. Maybe it's hard to remember, but it's easier to keep straight and not mix up. So I don't recommend the MAD formula. And again, the values that you need to know to be able to convert these to have the same units, we know that in 1 centimeter we have 10 millimeters. In 1 millimeter there are 1,000 micrometers, and in 1 micrometer there are 1,000 nanometers. Okay, so these are the things that you need to commit to memory, and make sure you know how to use to convert to the same unit, to use this formula. And there's a question on the 2122 weekly quiz that many of you got incorrect. So if you use this formula and try to figure out how to solve that problem, it'll be great practice to figure that out. You could also figure out the magnification of my drawing by using a ruler on your screen. Figure out what the drawn size is. Look up the actual size of the E. coli, or let's say it's 10 micrometers. Figure out how many times is this drawing magnified? How much larger is it than in reality? Okay.